Damn it, I was a couple seconds late. Oh, no. Back with CPP, but I have college tomorrow, so good night and good luck. Thank you, thank you. I will take that to heart as I make sure to... Oh, man. So, as I make sure to continue learning. So, last week, on Friday, my ISP decided that, hey, you don't get to finish your lesson today. And killed my stream. Very annoying, very unfortunate. And I want to do this on stream. So I haven't gone and done anything else. And then, of course, Monday was Labor Day. So we were a little bit distracted. And I made sure, I said, I put a community post saying, hey, there's no C++ tonight, or no streams at all until today. So now we're here today. And man, it always feels, for some reason, if I miss a day of streaming, it feels super awkward to come back for some reason. I don't know why, but it always feels like weird. But anyways, we're going to be continuing our lesson on templates. It was what was it called? It was function templates, if I recall correctly. Yes, function templates. Okay. And I wrote down our time code, our fucking... What did I call it? I have it on my desktop, but I have like a bunch of things blocking the way. What is our... Okay, here it is. So this one is sitting at the 18 hours, 17 minutes, and 38-second mark. Now, we're probably going to go back a couple of minutes just to make sure that there's nothing that we're like missing that's like insanely important or anything like that, because I'm not 100% on how much of this I remember. I do remember that one of the things that we did was we created anonymous templates or anonymous functions that we were able to call by using, I think it was a pair of parentheses. So let me get over here, and inevitably, surely, I will be, we'll have some stuff. Oh no. Oh, there we go. Okay. That was good. No, no, no scuff whatsoever there. So we're gonna go back probably 1 to 2 minutes and continue this lesson from here. I don't know how much more stuff there is gonna be for us to do. I know that there's about 40 minutes of lesson remaining, and we got cut a little bit short, so I was a little bit annoyed by that. So let's just I don't know. We'll go back like, I don't know, 2 minutes, 18 hours, 15 minutes or so. And continue from there and make sure that we're still like understanding what's going on. So do. And
that we might not get what we want, because what we get now depends on the address used to store these guys in memory. Hopefully you can see that. And let's try and debug this program so that you can really see this. We're going to use the tools from G++ or GCC, and we're going to try and debug it. Let's do that. It is going to
that's right. We were stepping through we were doing the debug, that the whole debug process. Okay, I'm remembering that. So this was our template type name T, and we used a T. This is the function of the text. This is our type name. So I guess if we use if we used like if we used a integer, it would automatically input integers for all these types. If we use doubles, it would automatically do that. Hello, I have to concentrate on veggies, so I don't listen to stream now, but have fun. I accidentally clicked 0.5 speed, so you sounded super drunk. Oh no. Well, that's fine, man. Don't worry about it. We're going to be recapping a little bit here anyway, so we need to make sure that we understand what's going on, because we got interrupted last time. So let's continue.
Through the debugger, and what we're going to have is our terminal here. I think this is not needed anymore, so let's put this to the right here and minimize a little bit. And now you notice that px contains an address and py contains an address. Hopefully you can see that in the body of our template instance, we're going to be comparing these addresses, because we're comparing what we pass by value here and what we pass are these two addresses. So whichever is the maximum in these guys, and I think that's going to be DD4 here. It is the maximum.
Yes.
So whatever is contained in PX is going to be considered the maximum.
That's right. So when we ran this last time, it was saying essentially that X is greater than Y here, but X is 5 and Y is 7. And that's because we passed these other variables these pointer variables to through here, which made it so that it was I think this one is considered greater than still, probably, but I don't know if that's necessarily set in stone, if that's something that has to I don't know if it won't give us the correct answer every time, is basically the point of it. So, yeah.
Because we have seen this information. So if we have a value in px and that happens to be at a bigger address, it's going to be considered the maximum. Let's see what we print if we run this program. We're going to build with GCC. Let's do that. The build is good. We can clear and run rooster. Now you see result is some address because we are returning a pointer and printing that out, but we can easily dereference this and get to the value inside this pointer. Let's build again. We can clear and run rooster. This is going to give us result is 5. And hopefully you can see that this is really bad and not correct. We are trying to compute the maximum between x and y, and we are seeing that the maximum is 5. So how can 5 be the maximum between 5 and 7? The problem is we're not comparing the values here. We are comparing the addresses stored in these pointers because that's what we are passing here. Hopefully you can really see this, and we can prove this again through our debugger. We can run this through the debugger. We're going to hit the breakpoint. Let's minimize this so that we can see our terminal window here, and we're going to move this around a little bit. And now we have hit our breakpoint. If we hit next to jump into the function, you see that what we are really comparing are A and B here, and A contains a much larger address, so it is the pointer that is going to be returned. And if we dereference that, we're going to be dereferencing the pointer that contains this X value. And the message here is that you should be careful that your function templates are really doing what you want. Somebody might do this if they are not careful, just pass in pointer and expect to get the maximum, but the compiler is just going to compare pointer addresses, and you're going to get something.
I mean, he already said it, but like with something like this, you'd have to dereference it.
Template instances won't always do what you want. A good example is when you call our maximum function with pointers, you're going to get a wrong value, possibly. There are tools like CPP Insights, which can show the template instantiations. We have seen that. And again, the arguments passed to a function template must support the operations that you are doing in your function template. We have seen an example of this by setting up a multiplication function template, and we saw that we had a compiler error if we tried to pass std string arguments because we can't multiply two strings.
The 0x stuff value is a hexadecimal number, in case you're wondering. Yeah, he explained that before. I think it was 0x is hexadecimal. I want to say just 0 was octal. And then there was like a b, like a lowercase b is binary. If I recall that correctly. And like I mean, these are locations in memory, right? Like it's an address. I mean, that's that is what is being passed here. It's 0 for octal. Is it? I don't remember that that being brought up. I remember that he covered octal. I don't remember it being 0. But it's been like 2 weeks since I heard about it, so I could have forgotten.
This is really all I had to share in this lecture. I apologize, it turned out to be lengthy, but I really had to put this in one lecture so that I can really show you different sides of the same things. We are going to stop here in this lecture. In the next one, we're going to learn about template type deduction and explicit arguments.
Okay.
Go ahead and finish up here and meet me there. In this lecture, we're going to learn about template type deduction and explicit arguments.
Okay, so we didn't miss too much.
Deduction is the mechanism the compiler uses to deduce the type it would use to set up our template instance from the arguments that we pass to our function call here. For example, the compiler is going to look at A and B here in our call to the maximum function, and it is going to notice that they are of int type. And then it is going to say, okay, you are calling your function with int types, and I see that your function template takes 3 replacers in here. So I am going to replace these guys with int. And it is going to guess that from the call that you make here, there's no other mechanism to help the compiler out. This is really what template type deduction is about.
Right.
And
this seems like it's kind of similar to the last thing.
Int parameters, so int is going to be deduced. For the second function call, we are passing in double parameters. So a double function template instance is going to be generated. For the third call here, we are using std string parameters. So we are going to deduce a template instance that uses std string here. This is what we mean by template type deduction. But we have seen that automatic template type deduction can really have problems, especially if you pass parameters of different types. For example, if we call our maximum function here with a and c, which happen to be int and double type, then we're going to have a problem because this function template can't handle parameters with different types. Because the replacer is the same, the compiler is going to enforce that all the template arguments are of the same type. And the template arguments are going to be what you pass in here. So a and b must be the same. If they happen to be not the same, for example, int and double, you're going to get a compiler error. Now we're going to see that we can use explicit template arguments. And again, I want to make it very clear the difference between a template parameter and a template argument. A template parameter is what you have in your function declaration or a definition. So what we have in our function setup here are template parameters. TA here and TB are template parameters. But what we have when we call our function template is going to be template arguments. For example, C and D here are template arguments. And we're going to be using this terminology in this chapter and many more chapters to come.
For some reason, I was confused on those terms.
So what we're going to do...
For some reason, I was confused with the template argument versus template parameter. But like it's just arguments. It's just parameters and arguments, and like what you're passing. For some reason, the word template was throwing me off, but it's literally just we're using the template with those two things. So
look at is using explicit template arguments, and what this means is a mechanism through which you can force the compiler to use some type to generate your template instance. And the syntax to do this is really simple. It is what we have here. We say maximum and we put the type we want to use to generate our template instance in angle brackets like we see here. So this is going to use double. So this is going to explicitly tell the compiler we want
that actually makes sense.
Code. And it's going to generate that, and that's what is going to be called by this call we have here. A good benefit with this is that now this is going to support template arguments of different types. So if we make the call like this, the compiler is going to see that, we are calling with int and double types because A is int and C is double, but it's going to see that you want the double template instance generated. Now the compiler will have the possibility to do implicit conversions from other types to double. And if this implicit conversion fails, then we're going to get a compiler error. So if you look here, for example, this is the example for that. We are passing in A and E, and A is int and E is an std string. We cannot do an implicit conversion from std string to double. So this is going to give us a compiler error. And this is really all template type deduction and explicit arguments are about. We can use these things to really make our code easier. Now that you have this understood, we're going to head over to Visual Studio Code and play with this a little more. Here.
Okay, so that actually kind of makes sense to the way that it looked. Like, let me go back one here. But so I was kind of unsure what this was when he initially pulled this thing up, but it kind of makes perfect sense given that this is the I think this whole thing is like it's not actually a signature, but it has the same like some of the same not signature, what is it? It's the same almost it almost looks like you're oh my god, my cats are being assholes. It almost looks like you're doing the same thing. Shit, dude. I'm like totally blanking on words and terminology. But like this looks a lot like when you're creating a not a header. It's like when you're declaring the like a function without first defining it. This portion of it is like kind of the same thing. It's like instead of template, you would have like your thing. Type name T is kind of no, sorry, it's this portion, I think. The declaring, like you have your like integer and then like your maximum, and then here are the parameters for the function. And then all we've really done here is, because we're using template, right? When we come over to this one, like, we can do our like the type name almost for like what kind of thing we want it to create. At least that's kind of in my mind. Like, it's very, I don't know, it makes sense looking at it now when it kind of didn't when I initially saw it. Versus like something like this is I think is fairly easy to understand on first blush. All right, let's see if using it is any different. I imagine we're probably still going to be using this, but I'm probably going to end up commenting out most of this other stuff.
Have this understood, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working directory. The current project is template type deductions and explicit arguments. We're going to grab our template files pretty quick and put them in place. And after that, we're going to open this in Visual Studio Code. Let's drag and drop on top of Visual Studio Code here. This is going to open our folder, and we can open our main CPP file and set up our function template. Let's clean this up a little bit, and we're going to set up our function template. Let's type this out just to practice. So we're going to say template, and we're going to say type name, and we're going to say T. And if you want, you can put this on a single line, but I prefer to put this on separate lines. But let's show you that. So we're going to say T here, and we're going to say maximum, and we're going to say the parameters.
It's going to be the same function.
Going to be of type T, and we can pass them by value just for now. And after this, we're going to go in the body of our function template, and then we can return whichever parameter is the maximum.
Yep, and we just go through.
B here. We're going to use our ternary operator, and if A is greater,
this is so fancy looking.
If B is greater, we're going to return B, and this is our function here. Okay, now that this function is set up, let's set up a few variables to really play with it. So we're going to include the string library because we're going to be using it a little bit. And we're going to go down in the main function and put in our few variables. We have A through F here. A and B are int, C and D are of type double, and E and F are of type std string.
All right, let's get our oh my god, dude, our variables. Jesus, get all these things in here, because I am trying to not entirely lose my mind. We have double C 34.7, double D 23.4. Oh my god. 1 second, guys, sorry. Couple of rude asses in my room trying to interrupt my learning. std string E hello, and std string world, and then it's going to return 0 because that's our main function.
The first thing we can do, we can say auto max, and we can assign whichever is the maximum between A and B. And once we do this, we're going to have that maximum stored in max here. Yep. But what I want you to see is what the compiler does when it sees the code like this. The compiler has no other outside help to know the function template instance it should really generate. It is going to look at the types we have here, A and B. It's going to see that they are of type int. It's going to see that it can use the function template we have here, and it's going to use that and generate a template instance that is going to take int, and it is going to call it to get our maximum here. Again, we can prove this through the debugger. We're going to set up a breakpoint. We're going to go to our run tab here, and we're going to run this through our debugger. We're going to build our thing, and when we hit the main function, you're going to see that A is 10, B is 23, which is what we have here. C, D, we have our values N, and std string, because it is a compound type or a custom type, we can expand on this and really see more information about this. But we don't have enough tools to really understand this by now. So we're going to just to use this as a wrapper on our string information here. Now, we want to call the maximum function and see what was generated by the compiler. And we can step into this function because we have hit the breakpoint by...
I hit a button. Uh-oh. What is this new allocator? Oh, it's because of the STD stuff. Okay. So let's try this again. But this time with this breakpoint. As he has it. Okay.
Now, so if we hit step into, we're going to step into this function, and we're going to see that it is an int function instance that was generated. This is enough for our purposes. If we change our call here to use C and D, we're going to generate a double instance. So let's do that. We're going to generate a double instance, and if we print this out, we're going to see this printed out. But we can use the debugger to really prove this, not that we know how to use it. We don't have to look through the terminal output window, but you can do that if you want. You can set up stdc out and print max here. You're going to see it printed out. So let's run our debugger. We're going to see the template instance that was generated through the debugger. We're going to hit the breakpoint at line 17 here. If we step inside, we're going to see the local variables for
maximum
our
double, double A, double B.
And we're going to have the maximum function to the top of the call stack. And you're going to see that it is a double instance for our function template.
Yep, it's
here.
done exactly what it says on the 10. Allocator is a class that literally just allocated memory in your RAM. It basically tells the RAM, hey, this user wants to create a string of this much length, so give me that many blocks. Oh. So, is this like, is it kind of, is it like when we had to mess with, like, the heap, and, like, it has to manually get released again, or is this still using the stack? Because I know that we have some things that do, like, when we have the STD string stuff, I know that we can just kind of have it, like, I can make this however long I want. Like, I could just do, like, an arbitrary length on it. But, like, does it, like, manually, quote-unquote manually, get released? Yeah, the heap. Oh. Ew. I assume that's part of, the string library? Or maybe? No. No. It wouldn't be that, because I think we've done stuff with just IOStream before. The heap is free memory that your program takes. Allocator creates memory allocations in it, but that allocation stays there until you release it yourself. Right. Yeah. So it's like manually, but like it's supposedly this is done at some other point in the code. In code that I have not written. Cuz he showed us how to be he kept saying responsible C++ citizens, and it was like if you finish using a pointer that was pointing at something on the heap, then you should make that pointer, like, after you release the memory, you need to make the pointer like specifically assign it to null pointer. And that was something that he stressed a lot. This is what causes C++ to have so many memory leaks because of bad code. Most modern languages use a garbage collector that frees memory automatically. I've heard the term garbage collector before in the context of code. I didn't really understand what it did or how it worked. Hopefully, I say I'm sure. Hopefully, at some point we'll learn about it and find out exactly why it is I'll find out exactly why it is. Anyways, let's continue with this.
By template type deduction. It is the default mechanism that the compiler uses to know which template instance to generate from your function calls. But as we have seen in the last lecture, this can be problematic. One way this can be bad is if you pass different types to the maximum function here. Let's pass in A and C, for example, or A and D. This is going to work equally well. You see that we get a compiler error because the compiler now, it sees that we are calling with different types, but the template parameters here are really of the same type. They should be of the same type because T is going to be replaced for a single type. So the code we do here
every
is
instance
going to
of
fail.
T is replaced with int or double or string. It can't be like T and does something else. I think last time you said that it was N is like the alternate an alternate variable, I guess, for the sake of a template. So you could do like T maximum and then TANB is my kind of my understanding. I never actually tested that. And then it would be two different types, but that still is only two types. Up to, I'm sure that maybe there's more after that.
Run this through the compiler again. Let's do that. We're going to use GCC. We're going to get a compiler error, and it is going to say deduce conflicting types for parameter T, int and double. So it can't really know which one you want. You want int or double. The compiler doesn't know, and it is going to.
I just used N for an example. You can use A, B, C, D, or whatever. Okay.
So
you can make it.
This work. And that's going
so
to
it just, but it has to be a capital letter by the looks of it, then, right? Like I could do something like this. Identifier A is undefined. Huh. Identifier N is undefined. Nope. Huh. I'm curious why T works no problem. But these other ones are telling me that it's undefined. Maybe you need to add type name A and then use A. Okay, that makes sense. So I'd have to create multiple templates with multiple type names, but the type names have to be, or would I just need to be? Would I just have to do like a second one saying type name N, or like if I did like that? That seems like it's worked. Yeah, so I don't need a whole other template. I would just need multiple type names by the looks of it. That's interesting. That's interesting indeed.
Template arguments. Okay, what we can do to do this, we can go down and put in our call. We're going to say auto and say result or max. We can call this however we want. We're going to say the name of the function, and we're going to specify the template type that we want generated for our function template here. So if we do something like this with double inside angle brackets here, we're going to be basically telling the compiler, please generate a double template instance for this call we are doing here. So if we pass in C and D, for example, this is going to give us what we want, and we can print this out if we want. So let's say max. Okay, this is going to work. If we build, let's build with GCC. Let's use that. The build is going to be good because we are passing in double arguments. And if we run this, we should see
all type names are declared in the same angular brackets normally. Type name A, type name B. Okay. So our C and D. Well, C and D should probably work either way, but
see our maximum. Let's bring up a terminal window and Visual Studio Code here so that we can use that to see things running. We're going to clear and run Rooster. You see that we have our maximum here. But using explicit template arguments like we are doing here is going to allow us to even pass different types for our template arguments. And for example, now we can change the first argument here to be A, which is going to be an int. And we're going to leave the second one to be D, which is of type double. Now the compiler is going to see that we're going to generate a template instance of type double, and it is going to know that it can do implicit conversions for the arguments we pass in here. So this is going to work if we pass an argument that is implicitly convertible to the type we passed in the angle brackets here. And let's debug this again to show you that we're going to generate a double template instance that is going to be called and give us the maximum that we print here. So we can run our debugger by hitting the green run button here. Let's minimize this so that we can see our terminal window, and it is down here. Let's grab it and put it to the left so that we can really see things printed out.
Look at that, we can see it. Maximum double, double A, double B.
Here, and we have our local
it does
variables.
our
You can
implicit,
look at this if you want. It is
as a result,
what
it's
we have
doing
in the main
implicit
function
conversion.
here. But what we want
This
is to step into this maximum function.
Floating point
and
error,
we're going
lol.
to see the template instance that was generated. You see that it is of double type here. Okay, hopefully now you can see that even if we passed different values for our template arguments, I should say different types, because A is of type int and D is of type double.
This still won't work with strings though, right?
The compiler is going to insert implicit conversions from whatever arguments we pass.
Because I don't think a string has an implicit conversion
argument that
to any
here.
double
Again,
or int
the explicit
value.
template argument, like we are doing here, using the syntax with angle brackets
Characters
and putting in
I
our
think.
type, is going to tell the compiler, please use this type and replace that for T in our function template here, and generate a template instance we can call to service this call here. And we're going to do implicit conversions basically from int to double, because that's what we want. Then D is going to be of double type. We're not going to do any implicit conversion. Then we're going to call this function. We're going to return a double from int because that's our template instance, and we're going to print that out here. This is what is happening, and we can prove that a double instance was generated through our call stack here. We see the maximum function is taking in double parameters, and it's going to return double as our explicit template argument here. This is the syntax that GCC is using, but we know now that it is a double template instance for our function call here. Okay, if you're not happy with what we are seeing with the debugger, you can also use CPP Insights to really prove this. Let's open this up. We're going to say CPP Insights. Let's do that, and we're going to have it open here. Okay, we're going to erase whatever we had in here, and we're going to put in another piece of code. We have our maximum function, I should say template function or function template.
Yeah, so CPP Insights we haven't,
and it is passing
I have it
types, A and D. Remember the last time we did something like this by passing in different types for
but all it does is show the exact same thing.
This guy failed. It couldn't really generate
not
function
the exact
template
same
instance
thing,
because the template parameters we have on top here specify that these guys should be of the same type. But now we are able to use different types as arguments because we have an explicit argument specified. Let's run this and see the template instance that is generated, and you can see that it is of double type. We basically replaced every instance of T here.
I'm going to assume as well that double, this doesn't work, like, this might, like, for obviously for maximum, you couldn't replace this with anything other than, I feel like it wouldn't make a whole lot of sense to replace it with stuff that isn't like some sort of number, right? You know, integers, doubles, you know, double, long, or whatever of those that you would want, but like, could you do one of these templates that like returns type void or something? If you feel something, you should try it. Worst thing, it won't run and you'll get an error. That's a good point. My cat is meowing at me for no reason. He's been fed. He's been loved. He's got water. I don't know what his problem is. I'm trying to learn. Like, I feel like for the yeah, okay. So for that function, it obviously doesn't make sense, but for this one, it makes sense. I think. When would I want to return void? I think that is something that could happen for a function. Hmm. Hmm.
Here with double, and this function is going to be called to service the call
Yeah.
we are
So
making here. Okay,
it
this is
creates the
really all we
double
set
thing.
out
We
to
already
do
talked
in
about
this
that though.
lecture. I hope you found it interesting. The main message was template type deduction, a default mechanism C++ uses to know which template instances to generate from your function calls. But if the defaults aren't working for you, you can use explicit template arguments to specify the template instance you want generated. We are going to stop here in this lecture. In the next one, we're going to see how we can pass template parameters by reference. Go ahead and finish up
Passing
here
template
and meet me
parameters
there.
by
In this
reference.
lecture, we're going to show you
You can just replace the return type t in the template with void. By the way, a function that doesn't return anything is called a procedure. Oh shit. I have not heard the term procedure yet. That's brand new terminology for me. A function that doesn't return anything is called a procedure. Hmm. You can just replace the return type t in the template with void. I would assume that's the not this. Would it be this part then? Replace that with void. Type name. No. No. Hmm. Don't worry. Don't let it worry you. A lot of terminologies here and there after all. A monad is just a monoid in a category of endofunctors. Oh Jesus, dude. I mean, I'm not super worried about like a lot of terminology because it's a lot of it is familiarity is the biggest thing. Because I mean, like, it's just like video games, but like actually, right? Like there's a lot of things that you'll run into in like video games that are like, okay, well, this doesn't really make any sense. But if you know, well, like when you've interacted with it enough, it's like, okay, now you're not speaking jargon at me. It actually makes sense. It's like any kind of jargon, really. I mean, like, what is it? There's like a famous string. How was it of words? Or it's like fucking PMCSV HMMW WVs before some shit, and it's just preventative maintenance checks and services, and it's like a whole like the military has a whole lot of jargon, right? Programming is like playing an RPG, but you don't know what but you don't know what plus 10 luck even does. Oh god, most of the time you don't luck is like the worst because it's never explained. The whole point of it is that you don't know what it does. Fucking Elder Scrolls. Yeah, let's just have a luck stat. It affects literally everything in tiny ways. Thanks guys. Thanks. Appreciate that one. Thank you, Bethesda. All right, template type parameters by reference. Now this one sounds interesting. I'm just gonna go ahead and comment this out instead of creating another whole new frickin' file. Template type parameters by reference. So we're gonna be doing these by reference, I guess. See, my first instinct is to do it by pointer. Like you have a thing like one of these, and then you pass a. You don't do it like this one because but like you just dereference it and then it's fine. But that's not passing by reference. You would have to be doing. Let's just listen to what the fuck it says.
That you can pass your template type parameters by reference. And we're going to look at a simple example to really drive this home. What we have seen so far is that we can do things like this and specify our T like this. And this is going to generate a template instance that passes arguments by value. For example, if we pass in double A and double B here for our maximum, we're going to generate a template instance which takes double as parameters and returns the double here. And this is going to be doing things by value. Okay, this is what I want you to focus on right now. It is that this is going to do things by value. So if we go in our function here and compute the maximum, you're going to see that the addresses we have on the outside are going to be different from the addresses we have on the inside here if we try to print them out. But you can also pass your template parameters by reference. And the syntax to do that is ridiculously easy. You just use this like you would use any reference. We say const t reference here. And this is going to just replace in whatever type that you pass when you call the function here. For example, here we are passing in double arguments. So this is going to deduce a double template instance, which basically says const double reference maximum, const double reference A, and const double reference B. And this is going to be the function that is called. So this is going to really do things by reference. And the values we have inside our function template body here are going to be true references to the values we have on the outside. If we happen to do any modification inside the body of the function, the modification is going to be visible on the outside. What we're going to be doing in this lecture is just printing the addresses here, and we're going to see that they are the same here on the outside and inside the body of our function template here. Okay, this is what we want to really play with in this lecture. But before we head over to Visual
confuse
Studio
your
Code,
compiler.
I want to show you that you can confuse your compiler if you are not careful. If you set up these two function templates you see here, they are going to be overloads, and we can use function overloads with templates. But for now, we're just going to focus on the parameters that we are passing in here. The first one is taking things by volume, and the second one is taking things by reference, as we see here. And if we issue a call like this, we're going to have the same problem we have seen with function overloads before. This is not going to know whether you are calling by value or by reference, and this is going to cause a compiler error. I really want you to be aware of this. Okay, now that you...
For this, I believe the const is not compulsory. It's just there to make sure people can't change the value of addresses. Yeah, so he's explained that before. I think that the main reason, like you generally, I would imagine, don't want people changing addresses if at all possible. Being able to change the address value of a pointer is so dangerous. Golang doesn't even allow pointer arithmetics. What is Golang? Is that like some other compiler or a different language? I've heard I know pointers are one of those things that like have messed people up before. Like, it doesn't seem too complicated to understand exactly what it does, but messing with pointers and like changing addresses accidentally seems like it would be fairly disastrous. Golang is another programming language based on C++. Okay. I assume, is it? I don't even really know what I'm asking with this, but like when it comes to is Golang like a memory safe thing? Like, I know it's based on C++, but like if you can't change the value, if you can't do pointer arithmetics, then is it like does it have other safeguards in place to stop you from fucking with things? Because one of my friends a while back, he was saying that, hey man, you should check out something like Python as well, and just see how much easier it is, or how like whatever. He was telling me that it was much easier, and that I should try any memory safe language, but I don't really understand exactly what that means because, like, this is my only exposure, so I don't know what the differences are, really. Say a pointer stores address 10 with a variable. Address 11 stores some important and vulnerable stuff. Hackers need to just do pointer p plus 1 where p is a pointer. Oh, so they just dereference the, like, the next address that has the important stuff in it, right? That's actually, that seems like a fairly exploitable weakness in C++. And that would be, that's the pointer arithmetics you mentioned before, right? Like, you can just do p plus 1. Like, you add essentially to the address of the pointer. What are you meowing about, bud? Huh? Huh? You know, if you wanted, you could just jump up in the chair. You have your own chair. You silly Billy. You silly Billy. All right, let's continue.
You notice we're going to head over to Visual Studio Code and really play with us a little more. Okay, here we are in our working folder. The current project is template parameters by reference. We're going to grab our template files and put them in place. So let's do that. And we are going to open this little guy in Visual Studio Code by dragging and dropping here. The folder is going to open up. We're going to open it and we're going to close the left pane here and clean up our main file here. And we are going to put in our function template. One thing I want you to see in this lecture is that it is possible to separate these things into function declaration and function definition. Let's just try and do that here so that you can really see this. And then you're going to have to choose what you like a little more. So let's grab our function header here and use that as our prototype. We're going to put that in front of the main function, and that's going to be our declaration. And if we go down after the main function here, what we have is our definition. This could work, and this is going to generate template.
Okay. I'm just going to have, what I'm going to do, I'm going to comment this whole thing out. I said, not the whole thing, but like this portion of it. And then I'm going to have it look like his so that we have our, so we have our declaration. And then this one that has the whole thing is going to be at the bottom here. And this will be our definition. And it looks like oh, whoops, wrong thing. There we go. There we go. This separate declaration and definition comes from C. Basically, in C, you had to tell the compiler you want to make a function before actually making that function. Isn't C++, from my understanding, is that it's like I don't know if fork is the right word, but it's like it's based on C. Like if I'm not mistaken, there was C, and then eventually there was C+, and then it was C++, or then C++. Or was it just C++ and then straight to C#? The later versions of C and C++ fixed that by allowing definition and declaration to be together. That's interesting that that's where it comes from. Yeah, it's like Age of Ultron if C is the Avengers. That's a ways back. At least it feels like it. Oh, this needs to be here. And we have our type name T, and then this whole thing. And then this one is our definition. Has all that same information, but it also has here cout in address of A. And then it shows address A. And line this whole thing. So this is the definition of this function. So it prints it out. And it tells us what's in here. And then it returns whatever's here.
Instances for the calls we do in the main function here. Okay, now that we have this, we can head in the main function and really play with the function template here. We're going to set up two double parameters, and we're going to call the function. For example, we say auto result, and we're going to call the maximum function, and we're going to pass in A and B. This is going to do default template type deduction, and it is going to generate a double function template instance here. But what we really want to prove is that this is going to pass things by value. And one way we have to prove this is to print the addresses both on the outside and on the inside of the function here. You see we are already doing that in our function template body.
Yeah.
We are going to print the address of A. So we can really grab this and reuse this stdc out statement. And we are going to change it to say out here. And we're going to print the address of A. Let's grab this again and use this after the function call. And what we expect to see is some address on the outside. So for example, we may have something like 0x and 111 ABC, which is some hex number here. And that's the same thing we're going to have on the outside, because the value we have before the function call and the value we have after the function call are going to be living at the same address. But what we have inside the function body is going to be a copy. So it's going to live at some other address, for example, let's say DA. And the main point here is that what we have on the outside is going to be different from what we have on the inside. And hopefully this is going to prove that we are passing by value. So let's print out our maximum here and see the addresses printed out. We're going to build with GCC, and we're going to build successfully. We can bring up a terminal to play with this a little more. We can clear and run rooster. We're going to see that the address on the outside ends in DD8, and the address on the outside ends with DD8 after the function call. But inside, you see that we have a different address.
Yep, different
this
address.
This is going to tell us that we are passing by value, and what we
and
have
this whole thing is
inside
actually different
the body
too,
of the function is basically a copy. Again,
yeah, so this
I don't expect you to see the same addresses as me here, because your operating system is going to set up the addresses however it wants. The main point here is that the addresses you see on the outside are going to be different from the addresses you see on the inside here. And this proves that we are passing by value. But what if you don't really want to pass by value and make your function template work by reference? Well, we can do that. We can change our function here to do things by reference, and all we have to do is use t reference like this. Okay, and when we start using references, we really need to be careful and make sure people don't modify things without our knowledge. And a good practice is to mark your things as const references. So we're going to do that. And we are going to do the same in our function definition. So we're going to change this to const t reference. Let's do that. And I'd say const t reference for the first parameter here, and say the same for the second parameter here. And this should be it.
Hold on. Const t reference, const t reference. And this one is const t reference. I think he had that for the down here as well. Oh wait, this one is down here. I gotta make sure I have our stuff. So the same. Const t reference, const t reference, const t reference. So now I'm going to back up like 10 seconds.
As const.
So we have const t reference, and then inside const t reference. Okay, no, this just needs to be t reference.
references. So we're going to do that. And we are
Oh,
going to do the
I was
same
wrong.
in our function definition. So we're going to change this to const t reference. Let's do that. And I'd say const t reference for the first parameter here, and say the same for the second parameter here. And this should be it.
Okay.
We shouldn't be able to use this reference to modify the data inside the body of the function, and our function is a little safer. But what the compiler is going to do is really what it's been doing all along. It's going to look at the arguments that we pass to the function call here. It's going to see that it is double, and it's going to do default template type deduction. So it's going to generate a double template instance for the function template here, and it's going to replace in double, and we're going to have const double reference maximum, const double reference A, const double reference B. And we can prove this by going into CPP Insights. I think we can do that. So we are here in CPP Insights. We can take out whatever we had. We're going to put in new code here, and we can hit the run button to generate our instances. And here we have our template instance here generated. You see that it is going to generate a double version of our function template here, and this is what we have.
Yeah. So this is doing this. It's doing the same thing that we've covered multiple times now.
A double explicit argument here.
The only difference is that now it's a double.
What we really care about is that it generated a double template instance for our function template here. Now, if we run this,
the only difference between this one and the ones that we've done before is that now, instead of being just a pass-by value, it's taking the address of whatever we passed in. So here, it's taking A, but then it's taking the address of A. Right. So it's like taking the it has the it's. I mean, it's passed by reference. It's passing. We're getting the whole thing. So when we run it, these three addresses should all be identical in when we do it.
It is going to be passing parameters by reference, and what we have on the inside should have the same address as what we have on the outside here. So to really drive this home, we should change our address to ABC to comply with what we have on the outside here. We can try and build our program. We're going to use GCC to do that. The build is going to be good. We're going to clear. And if we run Rooster, we should see the addresses being the same. Yep. Out DE0, in DE0, and out DE0. And you see now we are passing our parameters by reference. And if you want to set up a function template that passes template parameters by reference, this is how you can do this. And I think we can also try and debug this and see if we can see any more information on how this works. We're going to hit our run tab here, and we're going.
Yeah, C++ automatically converts A and B to their references for the function. On the other hand, if we were in C, we'd write maximum, and then we'd have to write in specifically the address A, address B, with the ampersands. Would we have to do that? Would we have to do that even if we had written the our function this way? I'm actually going to go ahead and... This is too long, I think. Yeah? Okay. I mean, that makes sense, I guess. I'm kind of curious how, I know, like, C++ and, like, C++ comes from C, and my understanding is that C# is, like, not newer, because they're all constantly in development, but, like, my understanding is that it's, like, there are aspects of each of them that is different, and I'm not clear on what those differences are. Like, from what it seems like is that C is a little bit more limited in what it does from C++. And I think certain things in C# are also different. I mean, that's such a vague statement that it's probably true, but it's one of those things where I don't really know anything better. C++ is similar to C. C# is similar to Java. Oh no. Everything I've heard about Java is that it's like basically like a meme language. Not that it's not like it's bad or anything like that, but it's like I've heard I've heard a lot of jokes about it, though of course I can't recall any of them now because it's always been stuff that I've seen from the outside. Do you need me to open the door so that you can leave? Is that what you need? Is that what you need, little guy? 1 second, I'm gonna open the door real quick. Alright, I'm back. C is almost low-level language. It's so close to the machine that it's used in coding kernels and other stuff. C++ is a high-level language version of C, so normies like us can code. What do you mean almost low-level language? I assume... Wait a second. I was under the impression C++ was a low-level language. Are there like multiple levels to this shit? Is it like you have like your highest level languages where it's like, you know, you're the manager and you tell the you tell the code monkeys what to do? And then like the code monkeys use a high level language that actually uses a low level language or some shit? Is this like some shit like the fucking that meme about the fucking what is it? Like it's like the anime's high school student council runs like the secret government that runs the secret that runs like all of the billionaires and shit that run the politicians that run the world. It's like fucking some insane bullshit going on. Let's see.
Going to hit the green button to start debugging this program. We're going to be using the debugging tools from GCC, and we see our local variables here. We have hit the breakpoint, and we have the main function to the top of the call stack. This is what we have here. And if we try and step into...
So go to our auto result here. Let's run and debug this. No, it's just low-level language and high-level language. Low-level language is like assembly and binary. High-level language is everything else. Okay. Okay, that makes sense. I don't know any... I've heard that assembly is like really hard to learn and is very complicated and difficult if you don't know especially if you're starting out. But then like binary is just completely or not completely, I shouldn't say. But like it's not a human language. It's just zeros and ones straight across with nary a break or anything to be found because it's what the computer understands.
To the maximum function, we're going to see that the template instance now is using const double references, and this is the template instance that was generated. I think this is all we can really see here. And let's stop this.
Look at this.
And show you one last...
Nobody codes in binary. Some poor souls code in assembly. Yeah, that's my understanding.
Function template that passes by a value, like, and the other one passing by reference.
I imagine it's theoretically possible to code in binary, but nobody does it because that's fucking dumb.
Let's change the second one here to pass by value. So we're going to remove the const reference here. I think it's going to do. Let's do that pretty quick. We'll remove the const and the reference. we remove the const and the reference here, and we use this guy as our function prototype in front
that's
of
the
the
wrong one.
main function here. And how can we say that? We're going to go on top here and say that. Okay, we're going to put our semicolon, and this is going to be our declaration. But the moment we do this, you see that our compiler is going to be confused because we have two possible candidates for the call here. It can either be by value or by reference. And if we try to build this program, we're going to get a compiler error, and it is basically going to be saying what is wrong here. So it's going to say call overloaded maximum double ambiguous, because we have two candidates again, one by reference, one by value, and this call can be surfaced by both of these candidates here. So the compiler is going to give us a compiler error.
You need to make sure
we have no
the
choice
compiler
but to
knows what
use
to
either
do.
of these two, but we can't have them all in our code. And for example, if we take out the one by value here and leave in the one by reference, so let's comment this out again. If we build, we're going to build. You see the build is good, and we're going to print our data however we have it in our code. We see the addresses are the same. And another thing I don't think I really proved to you is that we are passing by const reference here. So the template instance that is going to be generated is going to be passing by const double reference because we are passing in double parameters. But because of this const in front of our arguments here, we want to be able to modify the data referenced by this name here. If we go in...
Interesting. We had something similar to binary back when IBM just developed computers. There were punch cards that you had to put holes in a card, and those were interpreted as instructions by the hardware. I do remember learning about that when I was in like high school. And like punch card coding was like very, I mean, like it seems fucking insane to me. I have a friend who works on space robots. I think he has to use a combination of C++, Fortran, and I think punch cards. I don't know if Fortran is the punch cards. To fix the punch card shit, people developed assembly, but assembly was hard, so I believe the first high-level language, Fortran, was developed. Oh boy, the first high-level language. What the fuck? Fortran? That sounds insane. I need to ask him about like how exactly he juggles 3 different languages. I mean, he has to do like a bunch of different shit, but like dealing with punch cards from like the 60s cannot be easy. That's got to be one of those things that you're like, what do you mean I have to deal with punch cards today? Fuck that. Since when does FreeCodeCamp have a good C++ tutorial? That looks way too good. I mean, it's been uploaded since February 17, 2022. And this is like it's like 31 hours long. According to, I think it literally says learn C++ in 31 hours. And it's like, it's beginner to advanced. 31 hours. I mean, yeah. So far it's been pretty convenient. We're a little over halfway through. Let's see. FreeCodeCamp really got everything. I saw a mock technical interview video or something. I haven't actually seen a whole lot of stuff from FreeCodeCamp. I knew about this, but because I haven't really been doing any coding before, it was never in my peripheral. It was never closer than my peripherals, so yeah, that was for JavaScript, I believe. Oh man, maybe I need to get in on doing more stuff with this. Maybe there are more FreeCodeCamp things that I can do. I think I watched like some Fireship videos once upon a time. That's probably the closest I got to really doing coding stuff before, the last month. A really long time ago I learned Python from these guys. I've been recommended Python as after C++. because I've never. This is the only coding I've ever done. It's, and some of my friends were like, "Wait, you want to go with that? You don't want to do something a little easier?" Like, I mean, I'm stubborn. I'll figure it out. No, I don't. All right, I need to see. I need to see how much more. How much longer is this? This lesson I think isn't too much longer. I think it goes to the top of the hour. Yeah, this one's like another 16 minutes. We don't have that much stuff left to cover with this, I don't think.
Inside, for example, and say plus plus a, try to modify a in any way through this reference, we're going to get a compiler error. Let's build again, and
we're getting a compiler error for trying to use the, or for trying to increment a because it's const error, or because it's const. Yeah, if you learn C++, you're learning some really advanced topics so you can feel superior to everyone else. Hooray, TMP. I watched a Kotlin video when I was just getting started. Now I just read the docs the language devs put out. That sounds like that sounds like you're pretty high level then. It's just like, nah, I'm just going to read the documentation. I mean, like CPP reference is what Daniel Gakwaya has like pointed out multiple times. The main reason I'm doing this is just so I can go back to Unreal and actually know what the fuck I'm doing.
Going to see that, and build finished with an arrow, and it is saying increment of read-only reference a, because we are passing
and
by
it's a read-only reference
here.
because it's const.
So you should really remember this, even if we are doing things in the context of function templates.
I have bad news for Unreal Engine. Oh no, what's going on with that?
Set up function templates that take parameters by
Always
reference,
remember,
and
every minute that passes, we get
passing
closer to
value
classes.
and seeing the differences between these two things. We're going to stop here in this lecture. In the next one, we're going to learn about template specialization. Go ahead and finish up here and meet me there.
Oh, also CPP references is really great because that's where I learned C++. Yeah. I mean, it has a lot of good documentation, right? It's I don't know how you would like learn from it beyond like I feel like it would be so hard to tell what you started with, where to start when you look for something. It's like, oh, we're like fucking headers added in C++ 26. We're only messing with this. I think C++ 17 is the highest that our tutorial goes. I don't use C++ for development, just problem solving stuff on Leet and Code Forces. Oh my god. How do you even begin, like, figuring out what to do? I tried understanding iterators from fucking CPP reference and I almost killed myself. Oh my god. Oh boy, string view, and then there's like operator, begin, C begin, end, C end. And you can look at all of the different documentation. Oh no. Template parameters, character traits. Oh my god. Yeah, no, I'm not reading all of this stuff. I'm just gonna follow the tutorial, and then if I need to Google something, I will Google it. I have some level of Google foo in my mind. Iterators really be like that? Oh no. I had to talk for 20 minutes with a GCC developer to understand them. Holy shit. He needed to explain it to you personally. Like, dude, I don't get it. What are you talking about when you do this? All right, we should probably yeah, let's continue. Template specialization.
In this lecture, we're going to learn about template specialization, and this is a feature we have in C++ to bypass the default mechanism of how function templates work in C++. Okay, let's make myself super clear. Here we have a simple function template we have seen 1,000 times by now. It is the maximum function, and it is going to compute the maximum between a and b here, and it is going to return that. It is a function template, so if we pass in a and b, which are of type int, we're going to generate an int instance of the template here. If we pass in c and d of double type, we're going to generate a double instance of the function template here. If we pass in std string parameters, we're going to generate an std string instance of this template here.
I already knew programming before starting C, so I knew all I needed was basic input, output, file reading, functions, classes, and data structures like array, vectors, stacks. I suppose if you're already familiar with coding, it's not too difficult to pick up on some stuff like that. Can we do some backseat VS Code customization? I mean, I'm I I I have not messed with it at all. All I've done is like follow the tutorial 100%. So I don't know how I don't know exactly what you want to what you want to backseat. Oh no. Template meta programming. Oh no. Are we template meta? Is that what's going on here? What am I being pinged on? Oh. I'm sorry, but this VS Code is the programmer equivalent of a burning dumpster fire. What, like, just because is it like the colors and shit? I don't understand. I don't know what I'm looking. I don't know what the problem is. I just followed the tutorial, man. I just followed the tutorial.
And this is going to basically be comparing the parameters we pass. So we're basically going to say if a is greater than b, then return a. If a is not greater than b, then return b. Okay, that's going to work if what we're doing is what we have here. But the moment we pass something like what we have here, const car pointers, then we're going to have a problem. Because we're going to be calling our function template with
just pedantic shit, but turn off the white spaces rendering. I was told to turn on the white spaces rendering before. I had another friend. Fucking dude hasn't been here for, but he's fucking. He was like, dude, turn these on. I assume that that's what these are, the white spaces. Need to install the Yoru or Deep Dark theme from the marketplace at least. Oh no! All right, how do we do this side quest? Oh boy, welcome to programming. People tell you a ton of contradictory advice. Is it an extension? Install FreeCode ligatures. Oh no. Oh god. How do I do any of that shit? All I know how to do is boot VS Code. Let's see. This 4 squares under the debugger on the sidebar. Okay, so we have this. I have all of these things installed. I don't remember what these are. Install NeoVim. What do they even do? What is FreeCode ligatures? What is NeoVim? Arch Linux NeoVim? NeoVim is actually peak. VS Code NeoVim. This one? Search Deep Dark. Deep Dark. What? No, don't install Vim. That was a joke. I don't know what it is. There's Deep Dark material theme. Deep Dark. It's dark, deep. It's dark and scary, but it's easy on the eye. I use Arch Linux with NeoVim, by the way. Don't install Vim. What does it do? What? If it was a joke, but like I don't know why. The Abyss, the first one. All right, install. There's the default, and then there's the full black version. I don't know what the difference is. Set color theme. Default. Okay. Install a nice little font. It's called FreeCode. Some hate it, some love it. FreeCode. FreeCode nerd font. FreeCode and material and icon thing. Also for C++, turn on advanced modern linter. You don't need to install a font. It takes too long. Never mind. Oh boy. What is it? How do I turn on advanced modern linter? We're going on a side quest. What is advanced modern linter? I don't know what that is. Vim is like a text editor that can run on your terminal. Oh. Yeah, that sounds like a little bit too advanced for my needs. I use Mononoke as my font. Sadly, it doesn't have a lot of nerd icons, so I have to fall back on icons a lot. It's an extension. Advanced modern linter. An advanced modern static analysis extension for C, C++ that supports a number of back-end analyzer programs. Vim is a text editor that makes you not need to use your mouse. It's actually great, but a bit too complex. Oh boy. I mean, I suppose in the worst case scenario, I can always just disable something. Activation time, 132 milliseconds. Unable to activate Lizard Analyzer. Unable to activate Flaw Find Analyzer. Unable to activate FlexLint Analyzer. I don't know what these mean. Are these bad? Are those a problem? Is that normal? Oh god. Mononoke. Just do don't show again. Miss Tron, how goes it? It's going well, Steve. We're on a side quest. We're customizing my VS Code now. Alright. So now it looks like this. You might want to go into the extension settings and use a different C++ version. Look, I'm not gonna lie. I'm not gonna do that. Mainly because the first thing, the last time I did that, my fucking compiler didn't work at all. So this one has been working. I don't know what the fuck the problem was before. I wasn't able to get it to work. This was like before I even started streaming. I was trying to set it up in the first place, and I think the C++ thing I had was out of date. Are you using G++? Yes. Like GCC 14 point something, whatever it was when I installed it a month ago. You can try the Yoru theme too. I use that in my VS Code. Let's see. Yoru. A dark theme for VS Code. Yeah, why not? Let's try it. Let's take a look-see. Deep dark material. And Yoru. 14 something. It's complete, up to date. I'm not gonna lie, the themes are an endless rabbit hole. It's literally procrastination, but but less fun. Do G++ version. What, in the terminal? G++ version 14.1.0. I think turn off warnings was the better button. And when it comes up again, I'll do it. Oh boy. I have like 15 themes installed in my NeoVim. Oh my god. I remember messing with like my when I was in like high school, I had like my fucking I would mess with the school computer's Google Chrome theme every time, and I would sit at the same computer every time. Yeah, it's up to date. Yeah. I mean, this is the latest one. That at least a month ago. I mean, for fucking don't forget to compile with std equals C++ 2023. I think the one, if I'm not mistaken, where is it? I think the one that this one does is 20. If I'm not mistaken, this is the place where it is. Because that's what the tutorial said to do. I'd go with plus 23 nowadays. All right, I'll change it in my template file then. Here, let me, because I just copy that one. If I go to open folder, we're gonna do this shit, and it's gonna break something probably. Here, open this. Go to this. It's the tasks.json, and then or is it the properties? No, it's definitely not. I don't know what this is. I don't know why this is here. This seems completely pointless. Where are you? Plus 23. Yeah, I'm gonna save this one as. There we go. New. And I'm just gonna go ahead and folder, and we will go back to this thing. Oh boy. Oh boy. Turn on all warnings and where as well. This is actually necessary stuff, not just customization. Wall, G++ main CPP, wall, Wextra. Where am I putting that? In the JSON file, it doesn't seem to have any warning tags. The same place you put std in 20. Oh boy. Args. Yo, how goes? We're on a side quest. I just assume VS Code puts all that in. I guess not. Well, see, I had to manually create this shit. I have no idea what any of this is. All of this shit is from the very first tutorial where it says setting up tools. I have no idea how much of it is I have no idea anything else. This one is actually important though. Warnings are king. So you have the I just copy all of this stuff in quotations into args. Let me see. Let's do fucking... Wow, that was a fucking long ass goddamn. Oh, if I do that. Oh, shit. Warnings tell you when you're doing something stupid, and W error prevents you from ever compiling. Wait, not all of it's together. Well, yeah, I figure it's not all together. It's like, what is it? The... Oh... I don't know how all it fucking fits. What is it? Yeah. No. Hello, my name is John Wearer. So what we have? In here we have all. And there's, it looks like G++ main.cpp. I don't know how all this... W all. G++ main.cpp. Like this. Oh boy. Don't forget your commas. Wall. Wexta. Oh man. Okay. Those are all John's middle names. Wexta. Pedantic. Conversion. Non-virtual detour. Error. This is the... Don't put the G++... Man, I'm sorry for saying that. This thing. What the fuck is G++? Is there a ++ language for the entire alphabet? Well, G++ is the compiler, from what I understand. And all the entries have a dash before them, like dash wall, dash wexta. All these bad boys. Okay. Getting all this shit squared away. GNU is short for GNU's not Unix. Of course it is. It's kind of like... It's fucking recursive, isn't it? God damn it. It's like GIMP. GIMP image manipulation program. All right. Are these so this is all correct, hopefully, maybe, potentially. Anything that I'm anything else that I'm missing? Let me see. How many of these were there? Wall, wexta, pedantic, conversion, non-virtual detour. I hate recursive abbreviations. There's wine that's just wine is not an emulator. I messed with wine exactly one time when I was younger, and it was because my fucking computer was it was like a laptop that I had that my dad used to use for work, and it was a fucking it had Ubuntu on it in like 2006. something like that. I think RAII is the evilest abbreviation in all of programming. Why? Is it just RAII, RAII? What does it fucking mean? RA2? Is it is it not actually II? Romeo Alpha India India. Resource acquisition is not initialization. What? Would that not be RA? Resource acquisition is initialization. Why did I not put an A there? Accident. Okay. Wine is so crap. Was so crap in 2000s. It's actually really good. Really good though. Steam had their own fork called Proton that pretty much runs most games. I've heard that it's pretty good. Like the way that things have been going with Windows lately, man. If every fucking update is going to be like, if I ever get updated to Windows 11 and it's like, oh, by the way, we're gonna be taking screenshots of your fucking shit every like 30 seconds or whatever it was, and sending that to Microsoft, that might be enough for me to be like, no, I'm good. I don't need to do that. That's me, not you. I went to Linux after 11. Yeah, I'm still running frickin' uh Windows 10 for now. That's me, not you. All right. So I've got all this shit. Let me see. Go to view appearance. How do I change my colors and stuff? Set color theme. Full black version. Look at that. We're so cool. We're so edgy. Look at this shit. Try build and run now. File. What am I saying? Terminal. Run task. Oh, well, I have everything commented out, so of course nothing works. Duh. That's silly of me. We're going to go ahead and do just the basic shit. I think it was this one. All right. Oh, where did I forget it? I forgot it somewhere, clearly. Terminal, run task. Oh no. Expected an unqualified ID before return. Huh. Oh god, okay. It was just too many times I had to traverse through the catacombs of Windows settings to get all the way back to XP era. I think your side quest is pretty much done. Windows registry is so garbage. I'd much rather have a million dot files and environment variables than that. I've heard a lot of people complain about Windows, but the fact of the matter is, for me, it's very simple. It's rarely do I run into enough problems with it that I need to that it make me want to tear my hair out. Where have I forgotten it? It's not this, is it? There's no way. It's still finished with errors. Where am I forgetting my goddamn thing? Every C++ programmer knows that what they are doing knows what they are doing. Need a reminder that they don't know what they are doing. That's what warnings are for. Everyone who thinks they know what they're doing. Yeah. What did I fuck up? Line 63? The fuck? The int main is commented out, I believe. Oh. Is it this part? It says that it's overloaded as well. Hover your mouse over all the red lines. That means you have an error. Well, no shit, it means I have an error. Function template declared at line 6. Function template declared in line 54. These are two different things though, right? It's because of yeah, it's probably because they're both called maximum. Here, what if I change this to... Is it because I uncommented the wrong one? That could also be the case. Yeah, the main function is commented out. I mean, this part is commented out, but that was commented out before. Here, what if I just uncomment everything? And now I think that the problem is going to be that it's overloaded in a way that it doesn't know which one is correct. Yeah. Variable C is assigned a value that is never used. That makes sense. Yeah, so now we have it's got two separate ones that could potentially work, I think. So what if I just get rid of this one? If I just do this. Nope, still wrong. Oh. Oh no. We have our definition, we have this thing. Yeah, these things are never used. This is not used. These are addresses. Oh no. Here. All of these were never used. Remove the declaration, but not the definition. True. True. Alright, so now we have this thing. Redefinition of A with a different variable type. Okay, so then we have this thing. All of this was also taken out, I think. So now it shouldn't be redefining it. Ah, finally. Holy shit. Mark may be unused for everything that isn't used. This is how you do things with errors. Realistically, you should be using all your variables. Well, yeah, but the only reason that this is the way that it is because I don't want to make a new folder literally every single time that he changes some shit that's like and goes to the next lesson. So what I do is I just comment it out and then I'm like fucking I just continue. So like fucking I've had like the same lines of text many times over the course over the course of one file, and then I just close it, and eventually I'll move to another one. But it's like the only reason that half of this is here is because it's from like the last 3 sections of the lesson, which made it very difficult just now to figure out what the fuck was wrong. I love that Golang just throws an error if you have unused variable or imports. I mean, in its defense, it didn't throw an error, it just gave me a little blue line. I hate to be pedantic, but try making a new line after template for more readable code. What? After this template? This shit, none of this shit is readable right now. This shit's all fucking awful. You should take notes either physical or on some application like Obsidian. Spaghetti code is really hard to understand. I would, except that I suck at taking notes. After template type name T. Oh, this thing. He actually, you know what's funny about this is he actually mentioned he showed us when I was doing the lesson the first time. We did it like this, and he was like, "Yeah, like this time we're gonna do it this way because this also works, and some people will do this." But I like he mentions that he prefers doing it this way. When you declare the function, yeah. Because this is this basically is like, hey, we're going to use a fucking template function, and then here is the function, and it's gonna be fucking insane. All right, side quest complete, recustomized. We installed a bunch of bullshit. Hopefully, maybe it should be fine. I'm sure that this is going to be okay. Everything will be okay. When I'm learning a language, I just put comments below every single line. Like, this declares a variable. Every single time. It's like, yes, this declares a, a double variable. I can see that being a good idea for any kind of code where you're not the only person doing it. And probably if it probably has notes for yourself as well, but especially for other people who are trying to look at your shit, like, hey man, what did you mean by this? What was the purpose of this thing? All right, let's let's continue a little bit, shall we? This is the end of the file. This is the beginning. These are my headers.
The default mechanism is going to deduce a template instance that works on const char pointer arguments here. And what we're going to be comparing now are going to be pointers to the string rather than the string data itself. And hopefully you can see that this is going to be a problem. Template specialization is a mechanism we have to tell the compiler for a template function, if I pass you this type, please don't do the default thing you do of replacing in the argument type for the template parameter. Instead, use the implementation that I am going to give you. And you tell that to the compiler using the syntax we have here. You put a template keyword here, you put an empty pair of angle brackets, and then you specify your function the way you want it. You see it's going to return a const char pointer. The function name is maximum, which should be the same as the function template here. It's going to be specialized for const char pointer. So we specify an explicit template argument here, and then we pass our parameters, which are also of const char pointer. And when we do this, then we can head in the body of the function and do the comparison however we want. Okay, so how do we do this comparison here? Here is a simple implementation of the function template we just saw on the previous slide. You see that it really is the same thing. We have the template keyword, we have our angle brackets, and we have the function header here. It's going to return const char pointer. It's going to be called maximum, and an explicit template argument is specified within this.
Why are we doing const char
then
pointer?
we have our
I'm gonna go now. Good
what
night.
is really
Maybe good
important
evening or good
about this
afternoon because time
function
zones and
is
shit.
that
Yeah,
it's
man,
not
get
going
some
to do the
rest.
comparison we've been doing all along. It's going to use a built-in function in the C++ standard library, which is specialized for comparing C strings. Okay, if we come at CPP reference here and look at a function called strcmp, we have seen this before, I guess. It is going to
I
compare
guess.
two null terminated byte strings lexicographically. And you see, this is really what we want. We have two const char pointers. One is going to
Why
be
are
the
we using
first
const
parameter,
car
the other
pointer?
is
This
going
is
to be the
weird.
second parameter. We're going to compare them
Generally, I
and
just
look
trust
at
what he
the
says.
return
It's like,
value we
okay,
get from this
I'm
function.
sure it'll make
We're going
sense.
to get a negative return value if the first parameter comes before the second parameter in lexicographical order. We're going to get a 0 if they are equal, and we're going to get a positive value if the first parameter comes after the second parameter in lexicographical order. So we're going to use this information here and compare our two C strings here and return something in Visual Studio Code. Okay, so this is the function here. It's going to be using the logic from strcmp. And notice what we return. We're going to return whichever string compares greater to the other. So we're going to do strcmp. We're going to pass in our two arguments here. And we're going to say, if this returns something greater than 0, return A. Because in that case, A is greater than B lexicographically. This is the comparison we want to do here. And otherwise, you're going to return B. And this is going to compare our strings and not compare pointers directly, which is what we are trying to avoid here. And you see that template specialization is really helping out here. Now, if we have this in and the compiler sees a call like this, it's not going to compare pointers. It's going to use the template specialization because the compiler knows that this is a better fit for the call that we are doing here because we are passing const char pointers. This is how template specialization works, and it can really come in handy if you are doing things that work with pointers. We are going to head over to Visual Studio Code and play with this a little more.
Boy.
Okay, here we are in our working folder. The current project is template specialization. We're going to grab our template files. We're going to put them in place, and we're going to open this in Visual Studio Code by dragging and dropping on top of Visual Studio Code here. This is going to open our project, and we're going to clean it up a little bit. And we're going to close the left pane here. We don't need it anymore. The first thing we're going to do is to put in our function template. The same thing we have been doing for a gazillion times by now. The maximum function is going to return whichever is greater between A and B, and it is doing this by value. After that, we're going to head over in the main function and set up a piece of code to really play with us. We're going to set up a...
Oh, God, he just copies it all in. Fuck. Alright, we have our type name T. TATB. Returns these. Closing brace. Oh, yeah, I didn't. Whoopsies. Alright, there we go. And we have this shit.
Over in the main function and set up a...
Oh my god. He gets to just do this because he's the teacher. Fuck. Well, actually, I mean, it's like pretty much exactly the same thing as these. Okay. Well, in that case, what I'm going to do is I'm just going to move some of this shit down. Where is our... Below our strings, and then there's an int, max int. Here. I'm just going to copy this shit. Can't do it all. I mean, I can, but, like, I'm not going to. All this shit. And then we have int max. Max int is maximum A, B. Int type deduced. Int max double maximum C, D. Double type deduced. Well, duh. Then we have std string max str maximum ef string type deduced. Have you learned about classes yet? I have not. In fact, the only time I've interacted with classes so far has been uh, during when we learned about the one definition rule. The he started messing with classes and stuff, and it was basically just the point was to demonstrate that it works. That the ODR is for pretty much everything. But what it ended up doing is frustrating and confusing me because he just started putting stuff in that that hadn't been explained, and I didn't know what the fuck it was. So I have no idea really what that shit is. We have our max double. I think we get to them pretty soon, if I'm not mistaken, though. Let me see. We're in chapter 15. There's C++20 concepts crash course. Yeah, so we get to classes in chapter 17, which is going to be in only one more hour of video, apparently. I mean, an hour and 15. An hour and 20 from this point. But then after that, it's inheritance and polymorphism. And polymorphism is apparently like a fucking 5-hour section. 4.5-hour section. Which is kind of insane. That's the longest one, looks like. Longest chapter, I should say. Alright, so we have this one, and then we have std cout max str. And we have our max str std end line. Let's see, is there anything here that I'm missing? Are these equals supposed to be red?
Piece of code to really play with us. We're going to set up a few variables, and we're going to call our functions. So we're going to say maximum a and b. This is going to return the maximum between a and b. The compiler is going to deduce that the template instance should be of int type, so it's going to generate that and call it. It's going to give us the return value here. We can print it out and see it, and we're going to basically do the same for double type and string types here, and you're going to see that this is going to work just fine. So let's build this. We're going to use GCC to do that. The build is good. We can clear and bring up a terminal to run this and really see the output here. We can clear and run rooster. You see max int is 23 because that's what we have here. Max double 34, and that's what we have here, and we called max double to be of int type. We should use auto type deduction here to avoid these mistakes.
Look at that. We made a mistake already because we used int instead of auto. Shaking my damn head. But yeah, so with this one, with auto, it should automatically generate double. But I think this also probably works if we just do double manually, right?
Because the compiler can do this better than us. That's what we're going to do. And we're going to deduce max str here. And we're going to build again. Let's build
34.7, just like it's supposed to be.
That's my favorite compiler. I'm going to clear and run rooster. Now we have correct output. We have 23, which is the maximum between A and B. We have 34.7, which was deduced to be of type double here. And then we have the maximum strength, which happens to be world here. Again, when comparing strengths, the default is going to compare them lexicographically. And what that means, the one that comes after the other in alphabetical order is going to be greater. By that logic,
yeah, I actually do not recommend using auto there because it becomes unclear what the variable is.
Okay,
that is something that that's something that I think I kind of agree with. Has been a trend with this video over the little under 19 hours of watching it. Is like we use auto for a lot of things that are very very simple, like because this is like beginners coding, right? So like we use auto in a lot of places where we probably don't need to, and I wouldn't choose to. I probably like doing double here like makes perfect sense, and it functionally, like in this case it's functionally identical. but like when you look at it, you know exactly what you're getting. You know what the output's going to be because you said that it's going to be a double. But like there was I wish I could remember the exact example. There was like one time when I saw auto and I was like, okay, that actually it makes sense to use auto in this particular one. But like I think I don't know. Part of me thinks that it's kind of like uh what are so this is going to be a little bit of a difficult thing to explain. There are some extremely long and complicated unclear types, and auto is used there, iterators, for example. Yeah, hopefully I'll get to those at some point. I imagine I have to I'm making a bit of a leap here, but so if you're familiar at all with like army training and like basic training shit that you have there, one of the things that they do is the gas chamber, right? Where they give you a gas mask and you go into the chamber and it's just like tear gas that's in there, but you have the cold room which will have like basically none, and then the hot room. And like you go in, you wear the gas mask, and then and then what they tell you to do is that you take off the gas mask, and the purpose of this exercise is to show you that your equipment works and that you should trust your equipment. And that's kind of what I think he's doing here with auto, where it's like, okay, the compiler is doing the thing that we are telling you that it does, and we're demonstrating that by using auto because it automatically generates this, and we want you to, and I want to impress upon you that this thing works the way that the way that I'm explaining it does. And that's kind of the feeling that I get from this. You know, that sounds like fun. I mean, it feels like fun, doing it the first time because then they make you stand in there, and then it's like, oh, all right, fucking recite the Pledge of Allegiance or like the Soldier's Creed or whatever the hell, and you get fucking, you're sitting there like coughing like, uh, I pledge allegiance, and then like eventually, as everyone is like puking and throwing up because they um fail. I was proud because like there wasn't that many people who puked, but I was not one of like the 4 people who did, and I really wanted to. Oh man, that was good.
If we use const car pointers and try to call our maximum function template. And by that I mean doing something like this. We have 2 variables, g and h, which are of type const car pointer, so they are C strings. They are going to be null terminated because we are initializing them with a string literal, and we are comparing them here. We are saying maximum g and h, and we're going to print whichever is the maximum after we return that from the function. When the compiler says the call like this, it's going to do what it knows to do. It's going to replace an const car pointer in our function template here. So it's going to return const car pointer. It's going to pass the parameters as const car pointers. And we're going to be comparing these pointers here. And we're going to return...
Yeah, you'd be comparing the pointers and like it's let me see. If I'm looking at this properly,
pointers.
If my understanding is correct, when you pass this through, yeah, you're just doing you'd have to dereference these, I think, right? To do what you would expect it to do, right? Because it's, again, I mean, it was impressed upon us how important it is to dereference your pointers, like if you're trying to use the values in them. Right, so if we're trying to do this, if we're trying to compare wild or do a maximum function with wild and animal, like the one that it should give us is this one, because wild comes after a, and that's a larger number. But because it's just and these are pointers, this is actually a place in memory. Like G by itself does not is not wild. We'd need to, I think, dereference it in order to. By the way, you can use auto and function parameters. What, like in here? Like auto A, auto B? Oh my god. But why would you do that? What is that? In this case, at least this is a template, right? It's basically a cleaner way to make templates. It's actually great. Hmm. So you can replace T with auto. Like yeah, it would be like every instance of T here, right? It would be all four of them with auto, and it should just be the same, functionally speaking. Template yes and no. Template type name T. So like this. Still want type name T, but you can do auto erase template type name T. Yes and no. Oh, and no template type name T. Okay, that explains it. Yeah. So then it's like, so this is a template. That looks cleaner, right? Yeah. It is. It does seem cleaner. Makes me wonder why we do the template T stuff. Because like with this, as it is, right? What is this thing? Auto return without trailing return type. Deduced return types are a C++14 extension. Semantic issue. Well, we should be using 23, so that shouldn't be a problem. That's the equivalent of template type name T, type name U. Auto was added in C++20. Ah, interesting. But this, it did compile, so this should be fine. That's the advanced lint. You should upgrade it in settings. It's the static analysis tool. It's not upgraded. How do I upgrade it? It's the this one, right? Looks like it's updated. Click on the cog. I imagine extension settings. Flyant. Flylint. Flylint. Ignore parse errors. Exclude from paths. Defines, undefines, include paths, query URL base. Web query match set. Clang enable. Clang executable. Config file. You passed it. Standard. Language standards to check against. Cascade to all analyzers unless overridden in one or more analyzers. CPP Flylint standard. So I go to this and I do edit in settings.json. What now? It came up with this. I just switched C++ 11 to C++ 20. So I changed this to what, 23? Or just 20? And then I don't know about this C11 one. I don't know if there's like a newer one. I don't know if 23 works. All right, well then I'm going to leave it 20. And I don't know about the C11 one. I don't know if that needs changing. So yeah, it should not error anymore. Well, let's see. These settings. So it looks. I don't see any. It's not detecting any problems. So. All right, but yeah, this thing. Back to the actual lesson at hand. So these things worked as expected, with int 23 being our max int, and then our max double is 34.7, and then world unfortunately is incorrect. I'm pretty sure. Great, fixed. Yay! Unless you're supposed to change C11 to C20, but I don't think so. Yeah, it didn't. I mean, I just don't know. I haven't seen anything with C specifically. I'm pretty sure W is supposed to have a higher number value than animal, or than A, I should say, because it comes later in the alphabet, and it returned animal, but that's because, I'm pretty sure that's because of place in memory.
Going to replace an const card pointer in our function template here. So it's going to return const card pointer. It's going to pass the parameters as const card pointers, and we're going to be comparing these pointers here, and we're going to return whichever point.
Why is there a C style string variable? Is that just this std string shit? Because that's just the way that it's been done as far as I'm aware on here, on this tutorial. I have no idea what the fuck's going on. Const car character. Fucking, that's... I think it's for the purpose of this tutorial, from what I understand, from this, what is it? It's template specialization, I think. Speaking of, let me make my shit look like his shit again. It's interesting that this works, though. Template, type name, T max. We do this. Change this to T maximum, auto, TATB. There we go. Did you learn about function overloading already? Yes. We did function overloading, I think that was last chapter? No, chapter before that. It was sometime last week that I did it. Alright.
Pointer is greater. Again, here you must be noticing the problem. We're going to return whichever pointer is greater, and we're not going to be returning the actual string
Template specialization is function overloading.
Just the address.
Huh.
And this can be really wrong, because if the addresses happens to be messed up, we're going to get the wrong output. So let's try.
It's function overloading, but for templates. Is that... But like, templates we've already done. Wait a second. That make... Huh. Templates actually use function overloading. Oh. When you make a template, the compiler just makes a shit ton of functions for you. Right, yeah. So, like, because with like this one, right, it, like the template creates a function for that does this, but for int, and then it does one, in this case, it does one for double, and then in this case, it does one for string, right? So template specialization being, it is function overloading, essentially.
I am going to comment out what we had on top here because this could mess things up a little bit.
Just
So
a
I'm
little
going to
bit.
comment all this out and I am going to debug this. So we're going to look at this line here and I think we should say const car pointer result and say equals maximum g and h and I printed the result
It's
here.
automatic
This is going to make
overloading.
it easier to step into this.
All right, so let's copy to make our shit look like his shit. Makes it easier for all of us, I think. There we go. So we have our const car, wild const car animal, and this one we're creating const car pointer result maximum gh.
Function without the noise from stdc out here. So we're going to set up our breakpoint here. We're going to hit our run tab and we're going to debug this program and we're going to hit this breakpoint here. Let's see the types that we have inside our function call. So now that we are here, we're going to see that our locals are G and H and they contain our string. If we go inside,
I didn't set up a
we're going to
breakpoint.
see that G is really a pointer to the first element in our string here, and it contains W here, which is what we have here, and H is going to be a pointer to A. That's what we have here. Okay.
Does 10707 mean it's a 1 day long video? Yeah. It's 31 hours long. It's it's like I think it's 1 day, 7 hours, 7 minutes and 29 seconds. It's a really long video. Back in the day. So here we're looking at animal. I think it's funny that if you it shows here if you what the dereference is. And that W is or that the dereference for G is 119 W versus H is 97A.
And result is going to contain some junk data because it's not initialized yet. But we can step into this function and see things happening. A, again, is an address and B is an address. You see that the debugger is really smart. It's noticing that this is a pointer to a string and it's going to show us the string here. But what we compare are these two addresses.
In most computers, a car is just an int.
B lives in a larger address. It lives at address that ends in 55, and A lives at the address that ends in 50. So if we really execute this function, we're going to return the pointer to B, but you see that B is not really the greater string. And this is really something bad. You should be aware of this. This is what the compiler is doing by default, and it is going to give us a result that is not correct. Let's close this and see a way we can solve this problem, and we can use template specialization for this. What we really need is a way to compare C strings and not compare pointers like we are doing here. We're going to do that using a template specialization. And the syntax for this to work, you say template and you specify an empty pair of angle brackets. And then you specify whatever function you want to use. So we're going to go down here and specify that we want to return const car pointer. The function is going to be called maximum. We're going to specify an explicit template argument, which is of const car pointer because we want this template instance to work for const car pointers. So once we have this in, we're going to specify our parameters. We're going to say const car pointer A and const car pointer B. And we're going to head into the body of our function template here. Now, We have our two parameters and we're going to compare them as if they were const char strings. And we have seen that we have a built-in facility from the C++ standard library. It is this strcmp function. We can use it to compare two strings, and we're going to use the logic that we have here. So if the first parameter is less than the second parameter, I am talking in lexicographical order, we're going to return something negative. If they are equal, lexicographically, we're going to return 0. And if the first parameter is greater than the second parameter,
so yeah, those empty angle brackets are what the compiler automatically does for you.
A positive value. So let's transform this logic into a ternary operator. We're going to say return std_str_cmp. We can say that. And to have access to this function, we're going to need to include cstring. Let's do that. We're going to include the cstring library. And now we can say this, and we're going to pass in a and b, and we're going to ask ourselves, is this greater than 0? Okay, if it's greater than 0, then the first parameter is greater than the second parameter lexicographically, so we're going to return a. If it's not the case, we're going to return b. This is our ternary operator here, and it is going to work. Now that we have this n, the compiler is going to know we have a template specialization for const char pointer. If we call the function like we did here, calling the maximum function, the compiler is not going to use this function template we have on top here. It's going to see that this template specialization is better for the const char pointer type that we are passing here. And now, if we try to build and run the program,
really is just
the build
function
is going
overloading,
to be good.
but for
if
templates.
we clear and run rooster, we're going to see that now the maximum is wild.
Yeah, but in this case, you're explicitly declaring the template function, which is useful when you want different behaviors for different types. Huh. Well, that makes perfect sense then, doesn't it?
Let's see what we see if we don't have this specialization. We're going to comment this out because I don't think I really showed you. We're going to build again, and again, if we do this, this function template is going to be used, and you know that it is going to deduce a function that compares pointers directly, and that's going to be really bad. We can build this with GCC and really see what we get as output. We can clear and run rooster. Now you see that we are saying animal is the maximum between these two guys, but that's not true. Animal is less than wild in lexicographical order. We need a way to really compare C strings properly, and our template specialization is really doing that using the std_crmp function, and it is working pretty well. This is really all template specialization is all about. You're going to do this if the default function template you have is really not working according to your needs for the type that you want.
I mean, that's fucking weird. I mean, I know exactly how. I know why it does this. I think it's kind of funny because this could also be. I think this problem could also be solved by just dereferencing the pointers, right? But like, obviously, that's not the purpose of this exercise. Project 35. Look, man, I didn't notice that until like on Friday. Friday last week, I was like, oh my god, every single one of them is wrong. There's like 35, and I think I copied the first one and just did it a billion times. I will probably fix it for next week. C-style arrays use pointer arithmetic, so you don't need to dereference them. Huh. Is that pointer arithmetic? Arithmetic. So you don't need to dereference. Would I not have to dereference? I mean, like, let me finish this real quick and then ask my questions.
To use for this, and use this to your advantage because it's available to you, and now you know how to use this. The syntax is really simple. You say template and you say angle brackets, and then you specify whichever implementation you want for your specific type. For example, here, our specific type for which we want to specify this function template is const char pointer. You specify that as an explicit template argument, and then you specify your return value, your parameters, and you do whatever logic you need to do things right in the body of this template specialization here. I would like to welcome you in this new.
What the hell is concepts? Is this the first one of the... Okay, yeah, C++ 20 concepts crash course. Okay, so this is starting the next chapter. So we're gonna go ahead and let me real quick write down my... That is not the thing that I wanted. See, This is what I wanted. There we go. So we're gonna go ahead and do chapter 16. Write this down, and it's C++ 20 concepts crash course. And we're sitting. Obviously, it's already in the thing, but just in case for some godforsaken reason it gets taken away, we know exactly where we're starting. So we can do that, and I'm gonna go ahead and close this. What the fuck? He's teaching concepts. Is concepts that crazy? Did you learn what pointer arithmetic is? No. Not really. I did not learn what pointer arithmetic is. I understand, like, based on what the words are, I kind of understand what it sounds like it's supposed to be. I think I understand. Is concept such an insane thing to be learning? Because like the video ends with like 5 hours of polymorphism, and I don't, like, from what I understand, like what I understand is that I understand nothing, and polymorphism sounds like a really complicated word. Pointer plus 1 equals the next spot in memory. Yeah, that was explained. I think that I don't know if it was you or I forget who it was that mentioned it's like that certain things are unsafe, or that like hackers can do pointer arithmetic to access uh un uh access a different point in a place in memory, like if one is supposed to be secure and the other is not, or some shit. I mean, it's weird that he didn't teach classes yet. Classes are after concepts. That's apparently. Classes are supposed to be chapter 17 according to the video, and this one is chapter 16. I don't know how. I don't. I don't know, man. I'm just following the video. I don't fucking know what I'm doing. Oh. Oh my god. We've been at this for almost 3 hours. Well, 2.5 hours, but still, holy shit. That's a long time. Okay. I'm falling apart right now. I'm like fucking brain farting all of a sudden. I'm gonna save all this. And I'm gonna open my template real quick, make sure that my template is has all of the shit that I wanted it to have. Alright, so we have, this is the one that I've been using. The new one has all of this shit. So I'm gonna copy, I don't know how important it is that one JSON exists over another. I'm gonna try copying this stuff for the next one. You should do a quiz before moving on. Is there a quiz for this? Oh boy. Is there one that I can like do that's like for this level? Here's one. Oh boy. Close this thing. And let's go over to Oh shit, I'm getting asked a question, aren't I? Like, for some reason I was expecting a link, and now I'm suddenly having the realization that you're probably just typing out a question for me. Oh shit. Oh no. That's almost worse. That's personalized. All right, let me open this. Here, I'm gonna have my little. Let me see. Is this legible? Here's one question. Wow, that is not legible. What question? Boom, there we go. Haha, this is now large. You were talking about questions or something? If I had one, it is no longer a part of my brain, unfortunately. I think I think I think I had one. I don't remember what it was. Can now answer questions about coding. All right, but is there a quiz or something? You mentioned a quiz. Does FreeCodeCamp have them? Maybe there's one that I can do online that's like really basic. FreeCodeCamp quiz, developer quiz, learn to code RPG quiz. What? What link? I think YouTube is censoring my links. That is not terribly unlikely. Unfortunately, I can't do anything about that. What link? Chapter 11? Summary and quiz. Step 11 FreeCodeCamp. Chapter summary, color, C++. 11.x, chapter 11 summary and quiz. Function overloading. Is that the one that you were referring to? Alright, let me see if I can do a window capture. Learn CPP. There we go. Look, we're doing it live. There's never any scuff on this channel. Don't believe them if they tell you that's the case. Ah, no. Boom. There. Okay. Wait, does that mean YouTube censored my remarks about Learn CPP before? I was praising learncpp.com. I don't recall you saying anything about that, so that's not unlikely. All right, let's see. Nice work. Function templates may seem pretty complex, but they are a very powerful way to make your code work with objects of different types. We'll see a lot more template stuff in future chapters, so hold on to your hat. Chapter review. Function overloading allows us to create multiple functions with the same name, so long as each identically named function has different set of parameter types, or the functions can otherwise be differentiated. Such a function is called an overloaded function, or overload for short. Return types are not considered for differentiation. So this has a lot of text. I don't know if I necessarily need to read all of it. What is the output of this program and why? Okay, so we include IOStream, void print int x, std cout int x, and void print double x, end line, int main, short s5 print s, return 0. Let's see. I like how there's a show solution button. Okay. Let me zoom in a little bit. Make this look a little bit larger. There we go. So the output of this program, short is an int type. Yes, it was the it was like the 2-bit one or something like that. It was the smaller one. It takes less place in memory. I mean, so when I'm looking at this, we haven't declared int, or we haven't declared x for anything. So it looks like it would be int nothing, and then it would end the line. I don't think we've done anything with print. But I assume that it's supposed to be like a kind of like putting it to the terminal. And this is a double. Int main. std cout is inside the function. Oh, yeah, fuck, of course. Dude. These are functions. It's a print function, right? And then it's just puts x in the terminal, int x, and then it prints int, and then whatever x is. I understand the confusion. Do you? And then I know that this is an end line. This is something that we don't actually, the tutorial we've been following doesn't actually use. We use the one we've been doing is like endl. Print isn't anything special. It's just a function that the programmer created. Okay. /n is better than stdendl. So I've heard. I'm just curious because you're not the first person to tell me that, but it makes me wonder why. Here, let me make this. Well, here, we're gonna be in front of it. Boom. There we go. But I don't know why we're using endl if that's not the case, or if that's the case. Because he didn't explain that it was. I think he explained that it was like end line. I don't know. Maybe he didn't. But the output of this looks to me like it would be. We have our print int x double x. Oh fuck! Okay, I'm an idiot. These are parameters. We're not. This isn't a declaration of anything. Duh. Okay, so this one takes an integer. This one takes a double. This one is endl flushes the output buffer and /n doesn't. That's my copy pasta. Why? Okay. So we have our two functions. This one creates this one's a short. What is the output? this print int x, print double. If we print s, so we declare short as a, we declare s as a short with the number 5, and then the idea here would be that we print it. So I say, oh shit, I think that this does this throw an error? Okay, yeah, this is two functions of the same name overloading. Yeah, but does this one throw an error because this is a short and it's not actually one of these types? You're trying to feed it a you're using an argument that it doesn't like. A short is an int. Okay, so then the output should just be int 5 with like a space, right? The output is int 5. There. That's why it doesn't error. Remember implicit conversions, that's why it doesn't error. That makes sense. The output is int 5. Converting a short to an int is a numeric proportion, whereas converting a short to a double is a numeric conversion. The compiler will favor the option that is numeric promotion over the option that is a numeric conversion. Okay. So why won't the following compile? So that's -1 for me. Why won't the following compile? So we have a void print, so this one's just void end line. This is just to spit out a line by the looks of it. This doesn't have any parameters. Void print integer x equals 0. What? And this one is int x end line. Yeah, void end l. Void print double x. Std cout double. So this one, if we go in, void print int x equals 0 is a default parameter. If you put anything into the function, then int x equals 0. If you don't put anything into the function, then int x equals 0. Huh. So this feels like a completely different thing that I don't think I've ever done something with this. Because my understanding of that then is that like, assuming that you haven't like, if you call this without an argument, it just assumes the argument is 0. Void print double x. Exactly. Okay. But why won't the following compile? I assume it's a default parameter. Yeah. So this one would be fine. 5.0f. I would assume because this just has an argument that does not work. This is a float type. 5.0f is a float type. Does float implicitly convert to int or double? I would imagine that if it does anything, it would convert to double, but I don't think it does. There are things called promotions and conversions. Float can promote to double. Is that also done implicitly then? There's no shame in Googling this stuff. I mean, it is a quiz. I'd like to try and I'd like to try and figure out what the answer is. Why won't the following compile? Void print. Let's do this line. So we create a function called print that when called without arguments just spits out void end line. This looks like it just kind of ends. I'm actually not sure on this one, but I think it's the ambiguity of print with no arguments. Print can both refer to void print and void print int equals int 0. Oh, yeah, right. Because with this one, when you don't feed it an argument, right, it could do this one or this one, is what you're saying, right? And so the compiler doesn't know which one to call if you don't feed it an argument, which kind of makes this one like not good. Because like if you have a default parameter, you don't want to have one that has an empty parameter, right? Or an empty, oh yeah, empty parameter. Because if you want a default parameter, you don't. So it's because this thing is the way that it is. Because parameters with default arguments aren't counted for resolving overloaded functions. The compiler can't tell whether to call print or whether the call to print should resolve to print this one or print with the default parameter. Yeah. Yeah, that's probably why it won't compile. That does make sense. That actually, I should have been doing these all along. I didn't even consider trying to find them. This would have been great to continue to do. All right, so why won't the following compile? So we have void print long x, and then we have our stdc out long, and that's what this is what it does. And then we have our another one for double, and this one is does the same thing but for a double. And here we have print 5, and this won't compile. Okay. This one I can. We call the print function and we just feed it a 5. Oh, this one feels like it's. This one feels like I'm gonna feel silly if I don't get this one, I think. You can check out more quizzes. The chapters are aptly named. Is this kind of the same thing where it doesn't know whether it should do long or double again? Because these are double and long both take up the same amount of memory, right? I actually don't know why. I thought int could promote to long. Well, I think it could promote to double as well. I'm right? Oh boy. The literal 5 is an int. Converting int to a long or a double is a numeric conversion. The compiler will be unable to determine which function is a better match. I think it doesn't know whether to promote to double or long. Yeah. That makes that kind of makes sense because it's like the same issue that we had here, except it's two other ones where it's like it doesn't know which one is better. You know more C++ than me. Do not say shit like that. I will get a big head. Holy shit, how many questions are there? Okay, so there's 4 questions with a bunch of different points to them by the looks of it. Okay, let's... Oh wait, what? We did this one. Right, so... Wait, did I... Oh, okay, yeah, I did these things. Rock C++ genius, stop it! Bad. No. No. Write a function template named add that allows users to add 2 values of the same type. The following program should run. Write your add function template here. Oh boy. Can I? Oh, I would need to open my code again. Okay, hold on. And I have to create the following output. Wait, but this is just... Oh. Okay, so this is so what this is basically just creating multiple functions by the looks of it. Oh, I'd have to open my shit again. How much of this is there? Yeah, because I can't like write into this or anything. So we'd have add. What if I get my C++, my fucking notepad? Here, I'm gonna have to resize my shit. Boom, and then we do the notepad one, and I go. Look at that! I'm doing some shit. Okay, so just copy this whole thing. And we're calling it add. And we want to add 2 values of the same type. So we should do probably double A, double B. Probably, because we want decimals. And we can do like... We'll probably just take... Doesn't it? Let me just do a... we create something... What is the... Is it just result? Is that the word? Result equals A plus B. And then std cout addition result. I need to like this. Return A plus B. Oh, that's right. Return A plus B. Oh. And this shit is... Wait, shit. Oh. Fucking blanking, dude. This is all in Notepad, so I'm not even gonna try to run it. Is this? There's no point in writing anything beyond return a plus b though. Oh, that's right, because well, we'd still need to find a we'd need a way for it to output it, right? So fucking if we do Oh, because all of this is already done. Like all of this stuff is already in the fucking in this thing. STDC out add. Yeah. Do you know what return means? I know that it's we haven't when we first started, we did like the thing that I was initially doing. But like what exactly return like I understand that return basically gives this like this function's output is the number is whatever you choose to return, and like that's why from what I understand that's why the int main that's why it's always int main and then return 0. So if it returns anything but fucking 0, you know there's an error of some sort and it doesn't work. It's like from what I understand, I think I was told it's a safety measure, which I mean I get it, I guess. Return just makes the value of the function. Right, yeah. So add 2, 3, it gets you 5. Yeah, and then this one 1.2 and 3.4 gets you 4.6, which would be the thing. Wrote in Japanese in my journal. Why does hopeful have 3 kanji in it? Probably because it has something to do with hope for the future or some shit. And then this is going to be the same thing, except instead of return, or instead of a plus b, it'll be, uh-oh, here, we'll do this. We can do, it would be mult, and then we would return a times b, and then the results will be the same thing for this one. And then we, step 3 wants to subtract, so we would just do it again, but when we would do a minus b. I think you should compile your code because it's wrong for a weird reason. All right, let me get my shit running again. That's not what I wanted to press. Oh, well, that's not what I wanted either. I'm just gonna do. That's me, not you. Don't save. Whatever the fuck happened. Here, let's go to. Here. I'm gonna open a brand new one. Project 36. Oh, it doesn't even have my default stuff. Open folder. Rakanteki. Only writing in Japanese for journal entries now, no English, we hustling? Hell yeah, bro. Get that shit. Alright, we're gonna cut all this shit out. So, we're gonna copy this and, actually, where's my... Boom. I will get my shit in order shortly. Oh my god, I'm all fucked up. Ah! I'm all fucked up. There. Okay. Hopefully, maybe. Boom. Ah, fucking buttons. Wrong shit. Why is this? There. My god. Okay, let me move my shit over here. So, what is this? Saying explicit type is missing, int is assumed. Oh, that's right, yeah. Alright, so with this, copy this shit in. Oh, that's right, yeah. What it says, explicit type is missing, so it should be double add, and double mult, and double, I don't know why add is here twice, but, oh, that's why, because it's actually supposed to be, this one's supposed to be double sub. And also I need to do this. There we go. Your function has no type. Yep. It had no type whatsoever. But now each of these should return our thing. So write a function named add. The following program should run, and then it should produce the following output. So what it says is add our function template, so we just have the whole thing. So I think what it wants, yes, and this one should run mult, and then this one should run sub, and it returns the following stuff. So what we can do here, we're gonna fast track some of this stuff. And we're gonna do like this. Boom, boom, boom. So this whole thing, if we clear, let me run this real quick. Terminal, run task, G++. So our things 5, 4.6, and then it's 6, 3.6, and then 1, 1.5, 2.5. Still wrong, Lel. Run it to see why. I mean, it looks like it ran. It looks like it did everything correctly to me. What's the problem? Nihongo, oh god. Renshu suru no gaitsumo. Oh, sure. You are returning a double when you're supposed to return an int. Are we supposed to return an int? It's supposed to see a function template. Write a function template named mult. Oh. It allows the user to multiply one value of any type first parameter. A function template named add. So it's supposed to be function templates. Click on show solution. template, type name, auto sub tu, return. It's supposed to be templates. The function should return the same type as the first parameter. Sub. Wait, what? Okay, so this one, yeah. So these are supposed to be templates, not just functions. The function should return the same type as the first parameter. Yeah, so here, if we do, we'd need to go and change all of this shit to functions to be correct. Be template type name t. We're gonna get rid of all of these because they're all wrong, clearly. So this one's t add tx, or yeah, tx ty. And then it return x plus y. So this is essentially, your compiler is implicitly converting 5.0 to 5 on the output. So another compiler, it actually may show up as 5.0 instead of 5. Huh. Yeah, that makes sense. That makes sense. I did not complete this as we were supposed to. So then for this one, if we're writing a function for, this is the addition one. So then we go to step 2. So we're going to write a function template named mult. Okay, so we're going to do the same thing. We have our template. So we can do template, and it's I think we can just keep it type name t. I don't know if this will be a problem. We do t mult, and we do tx ty, and then here we do return x times y. And then this one should be correct now. So for this one, it should be, this is also wrong. How is this also wrong? Oh, because this one's supposed to have both. Oh, that's right. So this one has a double and another one. So we need to do a second type name. So if we do type name n, and we do fucking ny. So we just do it as a comma. Okay. So we have type name t, type name n. So we return, so we have t mult. So it returns the same type as the first one, you said. So this one should, the second one, when we do it, it should return a double, because the first one is a double. Stream delay? Oh, man. I mean, we're getting up here in time, right? 3.25 hours. All because I decided to keep doing like a quiz. Silly me. All right. So then this one should be squared away and good now. So then we need to create the last one, which normally we have to do these. Normally we'd do these in steps, but I decided fuck it, I'm doing it all right now, and we'll get our correct answers one way or the other. Write a function template named sub that allows the user to subtract two values of different types. The following program should run. All right, so this one should. My instinct is that this one is supposed to be similar to the last one, because we want two different types again. One value of any type with an integer. This one, two different types. This one, so this one, I'm not actually sure if this will work, but we'll see. So we do t sub, and it's tx and y. And then we do return x minus y. Except what type should the function be? That is the question. This is the instinct to create for this template. This is what immediately my brain wants to do. Write a function template named sub that allows the user to subtract two values of different types. So we need to be able to, in this example, subtract any double from any integer and any integer from any double, as well as two integers. If you do it that way, the function type will be limited to the first argument's type. You just found the number one use for the famous auto. I mean, could I then just change this to, could I make this just type name auto or something? I mean, we talked before about how you can just get rid of this and then just do auto No, auto as the function type. What, this thing? Auto? No, not the function type. What am I saying? I'm like brainless. Wait, so so like this? Auto sub tx and y? That way? Does this do it the way that we want it to, though? Is this not still limited with the first things? The compiler will automatically deduce what type should be returned depending on the t and n types. So it will always return the first one, supposedly. Or whatever is correct, rather. So like 3.5 minus 2 spits out 1.5. So it'll return a double. 4 minus 1.5 is 2.5, so that one should also return a double. But with the way I had it before, this would have tried to return an integer, right? Is that my understanding? It returns whatever the geniuses that make GCC decide. Yeah, you're right. All right. So let's terminal, run task, clear, and let's try this again. So this one should give us all the same answers, but be correct this time because we have the correct code. By the way, oh boy, before I hit enter. Oh. Template type name T, type name U is the same as auto fn, auto x, auto y. You saw this before. So let's go through our steps again. 5, 4.6. 6, 3.6. 1.1, 1.5, 2.5. But this time they're correct. Look at that. So you can completely replace the sub function with auto. You were right. Okay. Because that was like the get rid of this one and then it's auto, and then you just return X and Y. Okay. Let's look at this one. What is the output of this program and why? So we have our template, type name T, so we're creating a template function. Int count T. This is the same as int count tx, except we're not giving the parameter a name since we don't use the parameter. Static int C. Do you know what static variables are? I do not. I cannot honestly tell you that I do. I have never encountered statics. Ignore that quiz then. Oh, does the rest of it require... I mean, does the rest of it require statics? This one doesn't say anything about static. Yeah. And this is also like... This is the only the second to last... This is the second to last question. It looks like everything else is comments. Number 4 doesn't have any statics. All right, let's look at it. So we have int foo, int n, return n plus 10. So what is the... Yeah, we're looking at what the output is. Okay, so then we have a template called int foo, or there's a template function int foo t, or like we're calling it n, and then it returns n. Okay, so we have two functions here. One's a template function, the other is just a function. Both are called foo. Both return integers. stdcout foo1. So we feed it a 1, and then end line. Then we have a short s that we declare. It's the number 2. So then we have foo s, which looks like it should... It looks like it'll default to this because of the because it's a template. It's my guess. So it becomes an integer and returns this. So here we have 1, and then we have plus 10. So this one should return 11. This one should return a 2. Foo. We want it to return an int. So this one should return 14. This one we want to return an int. What the fuck? We want this one to return an int, but they both return ints. I would imagine because we're doing this, actually, maybe, so what is it? I think this one, I think almost certainly goes to, it returns 11. So let me, where's my goddamn, there, I'm just going to write it in here. So, boom, boom. So, number 1, I want to, these are my predictions. I'm going to look at the answers afterwards. So, number 1 I think returns 11. Because I think, like, it doesn't say anything specific. And when you call foo, I would imagine it would go with this one. Then number 2, you're still going? Yes. We're coming up on the end. This is like the last thing I'm doing. After I finish this question, whether I'm right or wrong, I'm gonna close up and go to bed. Or not bed, but get some dinner probably. Doing hard quizzes. It's hard for me. So number 2, this one, foo S. Now, I'm not sure about this. I'm not sure about this one. Instinctually, I want to go with this because you've specified something that isn't an integer, and this one doesn't have a specific parameter type because it's a template. So I would want to say that this one would just return the 2. Number 3, here we are specifying we want to return an integer. And I imagine because we're doing these angle brackets and saying return an integer, that tells me that we would want to use this one again. And so that one would return a 4. Now, I'm not confident on that answer because this one also returns an integer. I'm basing it entirely on the fact that we're using these angle brackets. I'm actually not sure whether short would go to foo int or foo short. I think it goes foo short. Surely it does foo short. This one I also assume would go with the template. And this one I think returns 2 again. So number 4, I think returns 2. We can't see the quiz through your head. Here, fucking, god damn it. Here, I'll do it like this. There, bam, look at that. You can still see my predictions and you can see the quiz. And then this one, number 5. I'm tempted to say this one would... Based on the logic I used for these, I think this one... I'm tempted to say this one also goes to the template. Yeah, I'm going to guess it returns 6. Now, I don't know. I'm really not sure about any of these. This one I'm fairly confident on. This one I'm a little bit less confident on. But then, like, all of these ones I'm kind of, my predictions are 11, 2, 14, 12, and 16. But I don't know. The thing is, I could see this one. I could see these returning. I could see because these are told to return as int. I could see it going to this one, but part of me wants to assume that because we're telling it specifically with the angle bracket thing, that it would go to the templates. 11, 2, 14, 12, 6. So it's good to see that we have a consensus. Wait, I know. Oh no. 11, 2, 14, 12, and 6. 11, 2, 14, 12, 6. Foo int makes a foo function. I actually know now the answer. Do you want to make it known before I click show solution? Because I'm not changing my answers now that I've made my guesses. My answers are in stone. Oh. Oh. 112426. But let's go. I might be wrong. Well, that last guess is the same as mine, so 112426. I'm right! Holy shit! Alright, in case 1, foo1 matches fooInt exactly, so non-template function fooInt called. In case 2, foo_s does not match non-template function fooInt exactly, but the argument s can be converted to int, so fooInt is a candidate. However, the compiler will prefer to use function template fooTT to stencil out exact match foo_short_short, so this calls foo_short_short. In case 3, fooInt4 is an explicit call to fooInt, so fooInt isn't considered. The compiler stencils out fooInt_int and calls it. In case 4, this is also an explicit call to fooInt. The compiler promotes argument s to an int to match the parameter. In case 5, syntax will only match function templates, so fooInt is not considered. FooInt_int is called. Actual genius. Yeah! Yeah! I'm a fucking genius, guys! I definitely didn't struggle. Not at all. Oh boy, oh boy. I should have been here for the lesson. You should have. We went on a whole side quest. You see, this is different now. We went on a whole fucking side quest. Definitely check out the table of contents. Let me see. Introduction, getting started. Oh god. Chapter 1 summary. Fundamental data types, constants, and strings. This has been moved, apparently. This one's split. Scope. Okay. We're on... Wow. References and pointers. I'm going to have to start doing some of these at the end of each day. Oh no. You got a paint job. Yep. And I would have told you to install a fucking font. We had a lot of shit. Oh, there's a lot of stuff here. There's a lot of stuff that I don't think we've actually covered. We got Introduction to C++ 23. All right. All right, though. I'm going to... It's been almost 4 hours at this point. Holy shit. So I'm going to go ahead and close all this down. Here, well... All of this stuff... I'm just going to comment the whole fucking... This whole document, pretty much. We're going to go ahead and close this. Close this. I got to close my freaking CMD. All right. So... Today has been a very full day of C++, I think. We've done a lot of shit today. We had a little bit of a side quest. Why are you doing that with your comments? I'm fucking... Because I'm probably not going to access that stuff again for a while. And if I do, it's probably going to be for reading. We did a lot of shit. So I'm looking forward to probably tomorrow. We're going to get into Chapter 16. Hopefully it doesn't run quite as long. But, you know, with as many side quests as we've been on today, all this shit. It'll be the same time tomorrow, 3 p.m. Eastern is when I start. And then we'll... I'm also planning to be live again later tonight. I haven't set up any waiting rooms for the week, but that's going to be for, like, gaming stuff. So, if that's of any interest, then there's that as well. But yeah, we'll be back later. Hope you guys have a good one. We will be... Okay, good later. Bye. I'm going to eat some food.